Good morning, everybody. As I say, my name is David Bott, and we have the first of a two-part workshop. For those of you who haven't been to any of the previous workshops, we have a format whereby we have three short talks on aspects of the battery supply chain, and then we go into breakout rooms where people can ask questions. This is the 9th. We've been running them. They're all bar the previous first are on the SCI YouTube channel, and some of them are corkers. I mean, they really are very good. And if you want an education in what's going on in the battery supply chain, then go look them up. If you can't find them, let us know and we'll do it. Have the next slide, please. Right, so this is the format for today. I'm going to just introduce the speakers and the concept, and then we're going to go on. If you're talking about doing work in the battery supply chain, you really ought to know about what the Faraday Institution and Innovate UK is doing. And to make sure that we do know that, Tom Bartlett's come along to talk to you about what the focus is, what the rationale of that focus is, and something about the competitions that are coming up and such in that area. This area is moderately unique in the UK in that it has a second stage funding mechanism known as the Advanced Propulsion Centre, which provides bigger sums of money for bigger projects further down the TRL level, further up the TRL levels. And they've been going for about almost 10 years now. And they also have actually a bigger thing, which I'm sure Hadi will explain. And Hadi's here to explain that. Hadi's been working in this area for a long time, so he knows a lot of people. And then finally, we're going to talk about what it's like to be in a project. WMG, which is part of the High Value Manufacturing Catapult, was designated the national centre for a lot of the scale-up work and the fundamental science 12 odd years ago. And Martin's actually come from industry and he works there, and he knows what it's like to be involved in meetings and the problems and the challenges you face. So we're going to go through that kind of link. And then, as I say, we're going to break into little breakout sessions. I think we've got 4 today, and you'll meet people in there who know a lot about things. So just go there, ask the questions, and learn as much as possible out of this, because this is the first of 2. On March the 14th, we're going to have an in-person meeting, which is the goal of which is to set up one or more consortia of people working in the battery supply chain, and that's why we're putting the effort into explaining where the funding is and what it's like to do, because we think it's really important that we get going. We've been at this, as I say, for about 3 or 4 years, and the end point was always a bit unsure. Now we know that we're going to have at least 2, probably 3 gigafactories in the UK, and they're going to need a lot of materials to make that work. Just for formalism, it's really nice if you can set your name in SCI to be your name and the organization you come from, to allow people who are talking to you, particularly in the breakout rooms, to make it easy. Okay, next slide. This is me when I was young and beautiful. Move quickly on. These are the 3 speakers, Tom Barlett, Hadi, and Martin Dowson, and you'll see a lot of them over the next 45 minutes. Next slide. This is organised by the SCI. The SCI is working with Faraday, APC, WMG, almost anybody. It's really important. We're a charity. We are a membership organisation. So if you're not a member and you're sitting here enjoying the things that we do, think about being a member, because it's really good. Okay, with that message from our sponsors, I'll turn over first to Tom. Tom?
Hi, David. Thanks for that. Let me just try and share my screen, make sure get the IT working very quickly. Go and okay. Are you seeing the notes side again?
Yeah.
Yep. Every time. There we go. All working?
Brilliant, Tom.
Perfect. Great. All right. Good morning, everyone. Thanks for the introduction. So, yeah, I'm Thomas Barlett. So I'm Deputy Director of something called the Faraday Battery Challenge. which is run out of Innovate UK, the UK's innovation agency. What I'm going to talk to you today is I'm going to try and set the scene a little bit on the battery side, just give a very quick introduction of sort of what the demand for batteries is, particularly through a UK lens. I won't go on into too much detail about it. We'll just talk through a little about the demand side, what that looks like in terms of the sort of batteries that we're going to be needing in the UK. And then also what because this is the SCI, what the materials sort of requirements are going into that, just in terms of the value that's hidden behind that, and also where there's opportunities as we're moving forward, especially over this next decade. And then what I'll probably update you on is some exciting announcements recently that we've done into some open access infrastructure, but also some live competitions that are open, both battery specific ones funded by the FBC, but also some more general opportunities that might be of interest to you that are coming up. So battery demand. So as you've probably heard, batteries are everywhere, and it's probably one of the hottest topics right now in terms of the net zero agenda. A lot of this is being driven by the automotive industry, and this is particularly because we now have these sort of legislative commitments for 2030 and 2035 in terms of the ban on sale of internal combustion engines. So in 2030, we won't be able to sell a pure internal combustion engine vehicle, and for 2035, then effectively hybrids then are phased out as well. So basically everything's going pure electric in the automotive space. What this means is that's generated demand as the whole of the automotive industry is pivoting to electric vehicles. What that looks like in the UK is we've got somewhere by 2030, we've got somewhere around a 90 gigawatt hour demand, and sort of a diminishing demand for other sectors, but still sort of potential growing demand in other sectors as well, where maybe legislative commitments are a little bit further behind, like sort of the heavy goods vehicle sector, but also emerging things, other things that are emerging as net zero is becoming a high priority. Things like stationary storage, some electrification of rail, where the electrification lines aren't quite all done, and also marine as well. So it's something where we're seeing the main demand being pushed through automotive, but other sectors also following behind. And as David very kindly mentioned, we're quite recently we've had a string of announcements around gigafactories, and we're now in a place where, thanks to things like the expansion up in the northeast of the envisioned AESC gigafactory, and also the announcement by Agratas of the Tata Group, we're starting to sort of fill in this demand sort of plot in terms of the batteries required to support our automotive industry. However, if you go to 2035, the demand is going to grow even further, and that's because of that second legislative sort of milestone. So while it's good, there's still lots and lots, hopefully lots more announcements to come. Lots more gigafactories need to be landed in the UK, but also with gigafactories comes the supply chain, and we'll talk about that a little bit later. So obviously this is quite a generic plot in terms of just talking about gigafactories and sort of battery capacity demand. But actually, what do those batteries look like? What are the needs, for performance requirements, the materials requirements that go into those batteries? Well, this is a bit of work we did. It's actually a couple of years old now, but it seems to still be ringing true. This is a bit of work that was done actually with Martin Dowson, who's also talking today, looking at the technical requirements for batteries for 2030, so that 90 gigawatt hours demand profile. And when you plot, effectively, this is at a pack level, so the packs that will go into vehicles. When you plot that on against sort of a watt hours per kilo, especially your energy your sort of mass entitlement and your volume entitlement, and on the bottom, you start getting this grouping of performance clusters for automotive. And at the very bottom, so you sort of very, sort of quite, minimal sort of performance requirements. You have things like urban utility vehicles, a bit more high performance. You're in sort of your high volume cars. This is where most of the volume is, about 60 gigawatt hours. The 90 is going to be in your high volume, call it everyday cars, small SUVs. And as you start walking up in performance, you start entering into things like the sports cars, your luxury large SUVs, your Range Rovers that the UK manufactures, and then all the way up to supercars. What we've also got on here is a few sort of current examples of sort of best in class. So the Neo ES6, very, very, these are sort of battery concept cars and things that come into market. Very, very sort of pushing the boundaries in terms of sort of the amount of batteries they can get in for a certain mass, and also the Merc EQ as well, really pushing, I think, the volume side. And the interesting thing about that is that the batteries that you need for supercars are not going to be the same for high volume cars and all the things in between. Those are going to need different batteries, different supply chains. And you can walk through that. So two very common battery chemistries are NMC, so high nickel-based chemistries, and also LFP, so your sort of iron-based chemistries. If you look at NMC, an indicative sort of performance profile or sort of envelope would be this. As you can see, not everything is being hit by current battery demands. Now, there's a couple of ways to get around this. One of which is to scale back your customer offer, which you know, if you're selling, I don't know, McLarens or something, probably isn't what you want to do. Or you need to really be investing in sort of things that are really pushing up that energy density, or really massively engineering those things to try and squeeze every little bit of energy density you possibly can out of them. When you look at LFP, which is an iron-based and generally a cheaper chemistry, that's been walking up in terms of performance for a little while now. And we're getting to a position actually where that chemistry can hit almost all of the performance requirements of the high volume segment, as well as the other segments as well. And that's really interesting because we can see that interplay play out over the next sort of decade or so in terms of Europe demand, but also Asian demand, as these sort of performance envelopes work in. And what you're seeing that play out in the industry is you're seeing car manufacturers either go for a pure nickel-based chemistry and effectively then depopulating modules or scaling back to sort of hit the requirements of sort of the lower cost requirements and lower performance requirements of high volume, or very large ones, maybe like Stellantis, are looking to do split chemistry. So where they can justify the whole supply chain logistics situation, you're then looking at having both an LFP chemistry to take cost of the lower performance, lower cost segments, and then a high nickel to take care of those segments as well. But it's obviously not just automotive. When you're looking at this and sort of LFP, you're also looking at really an overlap of static storage, energy storage, where you're seeing LFP take quite a leading role. And at the up end, if you're looking for maybe all electric flight, your eVTOLs and maybe light aircraft, you are really looking at high nickel chemistry to be able to even start talking about the energy densities you need to unlock that as a sensible route towards electrification. It's also worth pointing out that it's no point making a battery that's incredibly energy dense if it's got a massive, you know, really, really high volume energy density. It's actually mass, which is one of the limiting factors. So that's sort of the standard technologies we're talking through, but actually there are emerging technologies coming through, and this is where it gets quite interesting. So when you look down at the very bottom end, that sort of overlap with static storage is an opportunity for new technologies like sodium ion that are being commercialized to come in, start off in stationary storage, and then walk their way up into those low volume segments so you get the cost down and the volumes up. But also for very incumbent, maybe very high cost specialist batteries, things like lithium sulfur or solid state, what we think they're most likely going to be finding their niche is in those very hard to electrify, very high performance needs for things like supercars or maybe very high luxury sedans. And then as the volumes come up, efficiencies go and costs get cheaper, then they can walk down and start basically taking away market segment from some of the incumbent technologies. So as you can see, lots of different change, and each one of those battery technologies I talk about has a completely different supply chain behind it, or at least quite a varying supply chain behind it. If you're looking at a sodium ion supply chain versus maybe an LFP supply chain, there's very little that matches. So that's all very interesting. But the really interesting bit behind that is that all of that supply chain that's going to be sort of supplying those gigafactories in the UK, but also in Europe, is now being driven by this localization. And that's because of rules of origin. So effectively, the need to have a certain percentage of local production, and that local production means UK or EU, to remain tariff free for trade. And that's being walked up. This has changed recently. Before anyone questions it, this has changed recently. But what was happening is we were seeing these step ups up to 2027, where in 2027, 65% of the cell value or 70% of the pack value would need to be originating. What we've recently had announced, which is a quite good win for the industry, is that the 2024 scenario has been removed now. So there's a little bit more lead time to build up supply chain. But by 2027, that date is still fixed. And that really is putting the sort of the markers down for people building up the supply chain within Europe to meet all this gigafactory demand. And the reason for that is because when you look at this, I appreciate it's quite hard to see, but really what this is showing you is where all the different materials that are currently made for batteries are made. If you look at sort of your, I don't know, mined nickel, refined nickel, none of that's happening in Europe, really. A little bit in Russia, but not a lot. When you're looking at precursors, cathode materials, cells, all of that is happening outside of Europe, a little bit in Poland maybe at the moment, But all of that needs to be localized, and there's a lot of opportunity there, both for existing people coming in, but also new incumbents to really drive through some new opportunities. And to put that into perspective, some numbers from Benchmark Mineral Intelligence say that for cathode materials, there's going to be a 78% shortfall by 2035 in Europe. And for graphite, there's going to be about, let's say, a 777,000 ton graphite deficit by 2030 globally. So this is why there's going to be such a mismatch of materials, and why there's so much opportunity for people offering different solutions, potentials for materials or chemistries that don't require some of these very sought after input materials, and also people being able to offer those either at lower cost or greener and all the rest of it. So when you look at actually what goes into a battery, and when we look at this in terms of the value concept behind it, when you think of a gigafactory somewhere, you know, to sort of a 20 to 40 gigawatt hour factory is billions of investment. The supply chain is going to be following that, and the reason for that is because actually, when you look at a battery pack in terms of its the costs to go into its manufacture, over half of those costs are in the materials, are in sort of the active materials and the other materials. A lot of that's in the cathode. Quite a lot of that is in the other materials. It's in the separator, it's in the electrolytes, the salts, all the things that go into the cell the cell casings and all of that. Only about 20%-ish, it varies depending on cell, is actually value add from the gigafactory side of things, why they've got to be so efficient, so large. And then also when you're looking at pack manufacture, a lot of the materials then come back in, all of your pack materials to, you know, there's a lot of value to be captured within those markets. And this is why more and more attention is coming onto supply chain, both because of the supply chain opportunity, the localization opportunity, but also the value that's in there compared to just gigafactories as well. So that's great. I've just shown the demand and what we need to do. How are we going to deliver that? So in the UK, we've got sort of three plus one in terms of sort of things that we're considering. So one of which is that we need to deploy at scale technologies that are ready. And I think Hadi will touch on some of the work the ATF is doing specifically on making that happen. Develop those that are not, which I like to think the Faraday Battery Challenge and APC are really helping deliver that and try and de-risk that from a government point of view. And also research solutions to problems for decarbonisation that we cannot yet solve, which the FBC, through our partners at the Faraday Institution, are trying to set that long-term research up. And one thing that we've added in, I think, because it's becoming more and more of a concern, is also developing a skilled and productive workforce. The skills demand as we transition is huge, and that's something we need to work on. So the Faraday Battery Challenge, we're now a £610 million challenge. And we are, as I say, funded by government, run out of Innovate UK, to try and help industry meet that demand. And that's through a host of things on here, everything from supporting skills programs, collaborative research and development programs, working with private investors to try and get more money out of industry, helping policy standards, and also heavily investing in scale-up infrastructure as well, which I'll touch on a little bit. So we are more than just a provider of grants. We are really trying to be a holistic solution to try and help industry grow and meet this demand. But we sit as an ecosystem, and as David mentioned earlier, we're in a unique position in the battery industry where we have a very large organization called Faraday Battery Challenge that sits across this research, development, scale barriers. We have our partners at the Faraday Institution, over 500 researchers now across 10 major projects working on sort of the big industrial challenges, but getting academia to work through those and develop sort of the future thought that's going to really help us out in a few years' time. Innovate UK, where I am helping in the mid business innovation, and also the UK Battery Industrialisation Centre, our national manufacturing development centre for batteries, based in Coventry, which is now about over £200 million of investment into that capability. And we interface with Hadi and the rest of the team at APC, who then go on to deliver sort of more late stage research support, and also then into the capital support through the ATF programme. And it's specifically because of this where we act differently in the UK, and we think that we sort of punch above our weight, is because we do try and offer this sort of conveyor belt of support, both from research all the way through to industrialisation, and all of us are working together to try and deliver that in partnership with UK industry. So just while I've got a few minutes, I'm just going to quickly talk about some of the engagement opportunities that are live. Just I think that's more the main things we want to talk about today. From the Faraday Institution's point of view, so this is the research element. There's numerous opportunities to engage the FI. If you are interested in anything they are doing, please always reach out to them. But specifically, some things that might be of interest are these sort of three sort of offers that they do. There's also lots of other things they do through PhD internships and everything else. But both industry fellowships, where sort of basically the fellowships provided to academics to specifically work with industry partners. And this is part of making sure that this isn't just a research funded program. This is a applied research program that's actually delivering industry needs. So those 10 major programs are aligned to things like multi-scale modeling, recycling, cathode development, and we want and encourage industrial partners to get involved in that to help guide those researchers to answer the questions that really need answering. Our entrepreneurial fellowships, which are around putting academics into burgeoning startups and helping them grow and develop, and also sort of improving some of the technical de-risking elements through having an experienced academic helping develop those startups in their early bits, but also having academics learn what it's like to try and start up businesses and the industry challenges, so they can feed that back into their research and proliferate that through. And also industry sprints. So this is where you can call on those 500 researchers. If you have a certain technical problem you need to solve in your business, you're interested in something, you can basically hire out some academics across the FI and have them work on a specific problem for you, leverage their capabilities, leverage their facilities. As I say, it's about 500 researchers. I think it's 25 now universities involved across the UK. Pretty much all the ones you'd expect are in there. So that's quite always a good offer and always open for people to apply into that. Something we've got open at the moment as well. So this is we just had the briefing events. This is now live and closes on the 4th of April. Is we have our second round of our SME credit competition at UK BIC. So this is £1.5 million available to support SMEs to engage with the UK Battery Industrialisation Centre. And really, SMEs can use UK BIC for pretty much all of their processes in terms of mixing, coating, sitting, calendaring, everything you would want to make a battery. And this is also in terms of sort of online gauging systems, measurement systems, and also any data processing systems as well. It's not just about making batteries, it's also understanding how your material affects batteries. And I think that's really where the expertise of UKBIC comes in. So I'd say if you're ever interested about getting some materials, some sort of new innovation through, and you want to understand at a volume level how that would affect things, if you want to validate that, if you just want to understand the practical limitations of that, then to please reach out to UKBIC directly. They're involved in this project. And then hopefully you can get a good application together and we can support you through, I think the intervention rate's somewhere in the region of 45%. We can help lower the cost of entry of you sort of working with UKBIC over the next year. Another UKBIC slide, so sort of another announcement we have really, if you're paying attention to news, we've done a raft of investments into expanding the capabilities at UKBIC. And we're introducing something called this flexible industrialization line. This is going to be a line that's going to be jointly operated by UKBIC and WMG, and is now looking around £72 million of investment into, I would call it, this sort of flexible industrial line. So what this is going to be is effectively a smaller capability that sits somewhere between the facilities that you'd find in the universities and the catapults, that bridges the gap between, I would say, high volume manufacture, but also the sort of support you get in the labs. Sorry, we're going to be another minute or so. Construction is happening right now, and we're also in the position where that will be coming online. Different bits will be coming online and phasing out over the next 6 months, but will be fully operational at the very beginning of next year. Just to put it into perspective for you, I think I've got a nice animation here. This is the current sort of capabilities of UKBIC, so really sitting around hundreds of kilograms of material input to be able to use that and run that volume facility. With Phil, what we will be able to do is go down to more of tens of kilos of input materials. And that will allow UKBIC to support that journey from scale up, helping you bridge that gap between universities and high volume manufacture. I think I've only got one more slide, just about one more investment that we're doing. So related to that flexible industrialization line investment, we've now also announced 12 million of funding for something called the Advanced Materials Battery Industrialization Centre, or AMBIC. This is going to be a dual located facility at WMG down in the West Midlands and also CPI up in the Northeast. And this is really going to be capitalizing on already the great capabilities of those two organizations, but linking together in one facility. So this will be all about material scale up and processing. So looking at sort of 10 to 25 kilo batches of material, all of the capabilities and the process engineering support of CPI, and also validating that material through coating processes, but also cell trials at UK BIC. And what we specifically are doing is we tailored this facility so that this facility will be matched in output to the flexible industrialization line at UK BIC. So hopefully what we'll be in a position by the end of this year, but I do encourage you to reach out and start talking to people now, is you'll be able to support effectively from powder to pack and from lab to factory across all of our Catapult network and also the UK BIC. And it's going to put us in quite a unique position in the UK, where all of this stuff is going to be open access and also supported through our CR&D competitions, but also obviously for pay as you go services as well. And hopefully this will help de-risk a lot of people looking to try and develop materials and getting those validated cells in the UK. So my final parting words, I know we're probably running over time, is thanks for listening. We do have an innovation network where we try and match people and match opportunities and challenges. Please have a look at that if you can. There are even more open opportunities in Innovate that I've mentioned here. We do have our smart grants permanently open, which are sort of generic competitions. There is also a UK-Germany bilateral CR&D competition open. That batteries are in scope for that. Innovation loads and much more. Follow that link and you'll find all of the Innovate UK opportunities. If you have any further questions for me, just contact me in the email below.
Thank you, Thomas. And not to extend Thomas's talk, but I mean, it really is important to understand that the UK has been investing in this area for over 10 years. And when you see the UK BIC, if you come on March the 14th, or if you haven't seen it already, you should see it. It's awesome. This thing's been there and people need to use it. It's an opportunity. You can test out your materials as part of a battery. You can test out your technologies. It's awesome. And it leads on to the next speaker, APC, and Hadi. Hadi, can you take over the baton?
Yes, thanks, David. Can you see my screen? No, not yet. Can you see my screen now?
Yes, we can.
Excellent. Good morning, everyone. Thanks, David, for giving us the opportunity to talk to this group and not a new industrial sector and industrial colleagues, but a relevant one to the automotive sector. I'm Hadi Mortarzadeh from Advanced Propulsion Centre, APC UK. APC is a £1 billion joint venture between UK government and automotive industry, established in 2013. We actually celebrated our 10th anniversary last year. And the role of APC is supporting the automotive industry through different funding streams and of course, providing insights, foresights, technology and system level roadmaps to facilitate the transition of the automotive sector towards net zero. Since the beginning of APC, our focus has been mainly on vehicle technologies, subsystems, like batteries, like electric motors, fuel cell systems, and power electronics. However, cross-cutting themes and enablers like manufacturing supply chain, like digitalization, like chemicals and materials, and now energy infrastructure have always been embedded into our portfolio, and we have supported them through different funding programs and different R&D innovation support mechanisms. Let's just start with the fact that automotive is an important sector for the UK in terms of jobs. You can see the figures and export opportunities. Almost 80% of vehicles manufactured in this country are for export. Now it's not only about vehicles and final products. There are also export opportunities for subsystems, what is known as green technology exports opportunities, like battery management systems, battery systems, electric motors. But this huge supply chain and this huge sector poses a kind of huge challenge to decarbonization targets. The UK has set itself the target of becoming net zero by 2050. And there are obviously challenges which could turn into opportunities to improve the quality of the environment, opportunities to create and to develop and to manufacture low carbon and zero emission technologies in the UK, and opportunities for industry, for academia, and for government and policymakers to work together, supporting innovation and job creation throughout this journey and through automotive sector. What it means for the auto sector is the whole supply chain needs transitioning towards these net zero targets. It means it's not only about tailpipe emission, but looking at the vehicle system and the subsystem life cycle and end-to-end supply chain. Transport as a whole is responsible for 27% of UK emission today. So vehicle development cycle and the entire life cycle of the vehicles and their subsystems could really offer a significant opportunity to reduce the UK emissions. And this is our role, really, to facilitate the sector's journey towards net zero. We provide insights, foresights on key strategic technologies, on those 7 strategic technologies on the in the middle, to basically support the decarbonization of the UK automotive sector. And we of course provide funding through different funding mechanisms across the entire technology readiness level for R&D and innovation and commercialization of those technologies at scale at industry. A quick overview of our technology trends portfolio. We are responsible for developing and updating and refreshing Automotive Council roadmaps, which was published first time in 2008, and then with the birth of APC in 2013, APC has become the delivery mechanism for those roadmaps. We are now going through another refresh process, started last year, aiming to publish all of the updated and refreshed roadmaps by September this year, 2024. I'm sure many of you have been contacted and have been involved in this road mapping process and workshops and discussions we have with industry. The other piece of work we do is creating value chains for different technologies like batteries, including recycling of batteries, power electronics, electric machines, hydrogen, and so on. And we publish frequent insights and foresight pieces on these strategic technologies. As I mentioned, our automotive industry quarterly demand report, looking into the upstream supply chain for materials for different technologies, is published every quarter. The latest one was published just before Christmas. It's available for free on our website. Please take a look at it if you haven't already. And then we provide bespoke analysis on key mobility and transport trends, drivers, disruptors to auto industry. Moving on to funding and the funding streams we provide to support the transition of the sector. So we have this slide showing the technology readiness level of R&D innovation for the automotive for the automotive industry across the whole automotive R&D ecosystem, from fundamental research through to industrialization of those technologies at a scale. And you can see that at the research level, at the very low TRL level, we have a number of mechanisms from UK Research Innovation, UK Research and Innovation Agency, Innovate UK, EPSRC supporting that. Then it comes to slightly higher TRL, where likes of Faraday Battery Challenge, likes of Driving Electric Revolution Challenge, they support the development and the so supporting the innovation and R&D at that stage. And then it comes to higher TRL, where we have collaborative research development support, collaborative research development funding for application readiness of those technologies for auto sector. And then we have ATF, which is Automotive Transformation Fund, launched in 2020. And I'm going to talk about each individual funding mechanisms from APC, from TDAP at SME level to CR&D, collaborative research development, and ATF in more details in a moment. But this slide just shows where does it sit across the whole funding landscape, where we try to support the UK auto sector, complemented by those cross-sector funding mechanisms like Faraday Battery Challenge and Driving Electric Revolution, and Made Smarter Challenge, which is supporting digitalization. So it's basically having those pieces of jigsaw together to support industry throughout this journey of innovation and R&D for these new innovative green technologies. A little bit more details around each of our competition names, each of our funding streams, and the range of the funding available through each of them. The first two lines are under collaborative research development. We have CR&D and we have APC 25 open now. I'm going to talk about it in a moment. And we have Advanced Route to Market Demonstrator, ARMED, which we did the second ARMED program last year. We are planning to do a third one, hopefully this year, 2024, towards the second half of this calendar year, hopefully. ATF, which is aimed at developing upstream supply chain and material supply chain, really, for those strategic technologies like batteries. Thomas talked extensively about the importance and the significance of battery materials. I'm not going to bore you with that, just going to cover what support is available through ATF to make that happen. And then the TDAP, which is aimed at SMEs and spin-outs from universities, those smaller companies who could make a difference to the automotive sector in mid to longer term. And then we have NVN, which is Niche Vehicle Network, again, providing support with shorter duration, smaller amount of money, just supporting and facilitating networking with the wider and broader network across the automotive supply chain. Let's talk a little bit more details about our CR&D first. So the aim of CR&D, collaborative research development, is building UK capability and capacity in these emerging net zero propulsion technologies, and to basically accelerate the transition of the auto sector and this automotive supply chain throughout this journey, de-risking investment in manufacturing and a scale up for these technologies, and supporting the competitiveness of the UK automotive industry for those export targets and for those decarbonisation targets. The grant funding available through our CR&D is between 2.5 to 20 million pounds, which needs to be match funded 50% by industry, and the duration of the projects could span between 18 months up to 42 months duration. It could be for any subsystems or any technologies going on vehicle, for on and off highway automotive products. It's usually led by an OEM or a tier one, and it involves always SMEs, and in many cases R&D centers, RTOs, research technology organizations, and university partners and academia. APC 24 was closed last year. We opened APC 25 as the new CR&D program on the 15th of January, as of 2 weeks ago, well, last week, beginning of last week, and it's open until mid-March. So if you're interested and if you have an idea for an innovative project for batteries, for electric motors, for supply chain development, for automotive sector, please come forward, talk to us, and we would be more than happy to support you and to link you to OEMs and potential customers for your innovative solutions, or make you part of the bigger consortiums coming forward for this round of our CR&D program. On 3, as I said, we are hoping to open a new advanced route to market demonstrator core later this year. Automotive Transformation Fund, ATF, it's launched in 2020, another £1 billion investment from UK government. And the purpose of ATF has always been building upstream supply chain and building more resilience across the UK automotive supply chain, linking relevant supply chain from materials manufacturing side to UK automotive supply chain, making sure that the UK automotive sector is secure and it's transitioning at pace towards electrification and towards those net zero technologies. We have 3 sub themes under ATF around feasibility studies and capital investments, and again supporting R&D through ATF. The majority of the budget and the money from ATF usually goes into capital investment, where we have we try to support industry, or we support the supply chain to build factories, to acquire land or buildings or facilities, and try to contribute into the cost for those things. But before getting to that stage, we usually do a little bit of feasibility study around those opportunities and try to do a little bit linking it with potential R&D opportunities as well. So far we've done 3 competition rounds for feasibility study. Capital investment, it's an open EOI throughout the year. So EOI being expression of interest. So if you have an idea, you could come forward at any time and present your idea to APC, and then we will look into this and put it into the right format to make it a proper project if it's a feasible one. Or we would ask for a feasibility study to be done on those innovative projects before it gets to that stage. And R&D, I already covered that. We've done 22 projects so far through ATF R&D, which is a scale-up readiness validation before it gets to that capital investment level. The scope of ATF covers batteries, battery supply chain, electric machine supply chain, power electronics, and hydrogen fuel cell supply chain. And it's, as I said, and I repeat again, it's about building the upstream supply chain for all of these technologies, looking into the materials requirements for these specific technologies, what's needed on the upstream materials manufacturing supply chain to have a successful automotive supply chain for batteries, e-machines, power electronics, and fuel cell systems. And then finally, TDAP, a Technology Developer Accelerator Program. As I said, it's a unique and tailored package of support for startups and SMEs, which provides support in a structured way for early stage companies and startups and SMEs. Up to 170k grant is available through our TDAP program. Our TDAP is now open for application as well until 27th of February. So again, if you're an SME and if you are interested in putting an idea forward to get funded through our TDAP program and to become part of that automotive industry network, please come forward and we would be happy to support you and to have that discussion with you. So that's the end of my my talk, David. I tried to keep it to 15 minutes. It's now 17 minutes. Any question, or if you want to know any more details, please come forward, email us at that email address, resource email address, and it will be answered from our side. Thank you, David. Thanks.
Thank you, Hadi. So I hope you've heard from those two presentations that there's a bunch of people out there with money who want to build the supply chain, both the science level, the small scale up level, and now increasingly at the large scale up level. So it's about chemistry and chemically modifying materials and such that we need to do some more work. So the final talk this morning is from Martin Dowson. You've heard WMG and CPI be mentioned a lot. WMG had the first Energy Innovation Centre built back in 2013, and it's been expanding it ever since then. And CPI has been working alongside it for a good 5 or 6 years, but now has that big chunk of money that Tom talked about earlier. So it's really important. There are a lot of people from CPI and a couple from WMG here today, and you will meet a lot of them on the 14th if you come to the proper workshop, if you decide to join in. So Martin, can you please explain what it's like to be in a consortium? Martin?
Sorry,
Yeah.
Can you hear me okay?
We can hear you now, and it says Martin Dowson has started screen sharing, but it hasn't come to fruition on mine at least.
Okay. I'll stop sharing and I'll try again.
It worked earlier. Yes, it's there.
Popped up. Great. Okay, thanks. Yeah, I'm Martin Dowson. I'm head of electrification both within WMG and actually across the wider 7 high-value manufacturing catapults, which I'll touch on in a bit more. So basically, WMG, it can be slightly confusing to the external world. Fundamentally, we're an academic department in the University of Warwick. However, in addition, we're also one of the high-value manufacturing catapult centres, and we have a turnover of about 100 million. So it makes us untypical of a university. And also what makes us quite unique is that we're a mixture of academics and industry focused experienced engineers. So I've come from industry as an engineer with about 40 years experience in industry and only 4 years in academia. So the whole reason for WMG to exist is really industrial exploitation. So we're primarily here to help basically bridge the valley of death in the sort of 4 to 7 TRL phase and help industry innovation make it through to exploitation into UK PLC. So that's the sort of reason to exist, which means we've got quite a lot of experience working with collaborative R&D programs. And prior to WMG, I was working on collaborative R&D in industry. So I've probably been doing it for about 20 years. So I'll take you through some of the good and bad side. But because some of my later slides are a bit dull and boring, I'll put the colourful stuff in early. It's exciting in electrification. It's fun and different and challenging. So this, believe it or not, is from my last 18 months work, real projects we've worked on in electrification across sectors. So it's growing, it's diversifying, the challenges don't get any less, and there's plenty of opportunities. But as Thomas explained, the bulk of it is still dominated by volume automotive in terms of the GDP UK added value. However, there's still a significant niche and technical challenges to be met across all sectors. So in addition, there's quite a bit of material you can reference. As you've probably seen today, is one of the good things we have is a fairly well thought out and joined up battery ecosystem, from the funding mechanisms all the way through to the actual hardware on the ground to enable scale up and technology development in the UK. So it's probably unrivaled in any other technology in the UK and across the world. And there's quite a lot of material Hadi's APC roadmaps, where we all contribute through to UK government publications and our own. So we do try to all join up as a coherent ecosystem and cross technologies and aerospace as well. But the APC are the dominant effective customer for battery technology. So please have a look at the APC roadmaps to get further detailed info. And to expand a bit on what Thomas and David said, is this is my alternative version of Thomas's map to show scale up and the ecosystem that's actually going in to aid people like yourselves from gram scale sort of chemistry materials research all the way through to full volume manufacturer capability through UK BIC. Battery world is a very interesting and complex one because as well as the detailed technical challenges, it's very sensitive to where you are in the scale up and manufacturing process. So it's not just proving your technology at a small academic gram scale. As you move through the larger scale up formats, go into different cell formats, into different volumes, different manufacturing technologies, it actually all changes how your solutions work, and you need to be able to prove out at all these different scales and interactions, which is why fundamentally we're trying to put in place the ecosystem to do this, because the level of investment required would never be affordable to the bulk of UK manufacturing. So it's one of the sort of prerequisites to proving technologies, giving OEMs or the end customer confidence in your products, is demonstrating capability at all these different scales. And the UK is hopefully leading the way on enabling that ecosystem for you to do that. But really sort of finally to move on to what I was really here to discuss, and I don't have many slides to actually show this visually, and it's more trying to talk you through it, and some of it I'd rather not go into print on. What is a collaborative project? Basically, it's multiple partners working together on aligned research that matches funding bodies' strategic funding calls. And ultimately for us, it's UK PLC exploitation. So there's a lot of different routes. So you've seen things today from the Faraday team through Innovate and APC, but there's also ATI, and there's actually quite a lot as well coming through the materials funding bodies on recycling, etc. So they all actually align behind a standard model, normally run by Innovate UK, where you have to have a consortium pulled together, and the whole aim of it really is, from the manufacturer's perspective, is leveraging government funding to support strategic R&D. So that's why I've sort of signaled a lot of the strategic documents that will give you direction on where we think the direction of travel is, and that's partly also where the funding calls will be aligned to, and where your technology solutions should meet a strategic need and gap. It isn't just a pure financial one, but not to underplay this, and why I won't go into print, because some of the finance team and accountants will squeal a bit. I know plenty of companies and small SMEs who basically this is a lifeline for. You don't get fully funded. It depends on the scale of your organization. Smaller organizations could be up to 70% funded, 75%. Larger OEMs can be down at around 50%, but there is a cap on overall levels of grant recovery. But this is against your organization's agreed overheads with Innovate UK, and depending how you're structured with variable and fixed costs, this is why a lot of SMEs find it can actually be a vital lifeline to keep a significant proportion of their business ticking over. It's not the only reason to do it. In fact, the primary reason really is more learning from other partners in the workstream, but mainly building potential supply chain relationships off the critical path and de-risking product development. and I'll also touch on what it isn't, and some people in the past I've worked with have misunderstood this. It isn't a supplier sourcing commitment. So just because your partner's on a collaborative R&D project doesn't necessarily mean you will get the volume business from the partners further downstream. It's not that commitment, but it's more like a soft sort of dating agency and opportunity to shine and engage and learn. It also isn't meant to be a subsidized production delivery program. It's there where there is still a level of risk normally, and helping you bridge that gap. It's definitely beneficial. However, it is critical really on setting up the partnerships. Normally the funding calls will sort of mandate a level of partners, how many, what's the minimum, and a cross section. It's good to have a range of partners in both scale and across the sort of TRL, MRL development level, and normally have an academic or RTO research organization as part of it. What you normally need to do is try and actually build these relationships ahead of funding calls. They're not necessarily putting bids in, isn't as quick to do as some people think. My nightmare is usually 7 days before the end of a funding call deadline, someone phones me up and goes, "Can you be a partner?" We don't know who all the other partners are, and we haven't totally defined the work streams, but yeah, we can do it in 7 days. That's not the best way to start. Normally it's through events like this and other events that will be held in the future that you start building relationships with other possible partners around a technology or theme, or a UK potential exploitation, so that you're ahead of the curve before funding calls come on, and you've already almost hunting for the appropriate funding call with a ready-made proposition and work streams defined. Where it really works well is where everyone's got a clear vision of success, and the work streams within the funding call are well thought out and aligned behind a vision, and the partners are open and trusting. But also one of the main things is that people do need to put up investment and time to work collaboratively. I've just come out of a partnership program with Jaguar Land Rover, which was an APC funded £25 million project overall. And it was one of the best we've ever done, where the Jaguar Land Rover actually put some resource and effort behind it. So even though our work stream was relatively self-contained, they were the end customer for the information and knowledge and exploitation. And what they did was actually dig out the real customers within their business, who actually had weekly meetings with us and helped shape the requirements and bought off the structure of the research and the testing programs and the validation. So all the way through, when it came to exploitation at the end of the project, we could easily demonstrate to the APC routes to market and exploitation. And that was a very good example. Other ones we've seen, people can just leave you to your work stream and you get no engagement, and then trying to prove the exploitation and get value added is very hard. So really you get out what you put in. The other thing behind it, and I put a link on it, is there's plenty of material you can look to, is you do also need good collaboration agreements and understanding up front, particularly around the IP side, who owns rights to what, background and foreground IP, etc., and exactly what the roles of the partners are and the aims and objectives are complementary. So that's a very brief whiz through. I think I probably saved a couple of minutes to get back on track, but if there's any questions, we can really get through to that in the breakout stuff. But the main thing is normally around it's speed dating and partnership building is the critical phase, and do it early.
Thank you, Martin. Brilliant. And you may not have put it on the slides, but it's all being recorded. Okay, just to close out this section, 3 great talks from people. What you should take away from this, if you've never met them, is they actually care. They want to make this work across all the supply chain. They will answer questions. We will get together their presentations, and particularly those email addresses they all put up about, if you have a question, please. And that goes for us as well, if you want to contact the SCI, because we come at it from the chemistry side of things and such. But we've been working together with, this series of workshops has been heavily populated by speakers from APC, Faraday, and all the companies that we've met on the way. And it's the active components, it's the passive components that without which it doesn't work. We need to do a lot. We need to build a huge capacity in the UK over the next 5 to 10 years if we're going to realize the potential. I mean, as I said before we went down, SCI is a charity and it needs members. So please think about being a member. If you're interested in taking part in March the 14th, let Callum or Harvey know soon. We're going to be putting up the website soon. We're going to be organizing what's going on. But the intention is to explore with the funders and with some of the providers that the funders have set up over the last decade, the potential for actually building consortia in this area, which is what we need to do. And I think Martin's point about you might not be in a consortium this time, but you'll meet some interesting people on the 14th, and you may want to work in them. If you see the facilities that WMG have at the Energy Innovation Centre, and particularly UK BIC have at the Industrialisation Centre, it's awesome. I mean, BIC is effectively a small gigafactory. I think it's 650 megawatts, if I remember rightly. So rounding errors would take it to being a gigafactory. But it's just really important that we do something in this area. The chemical and chemistry industries have to do something to enable this. It's a huge opportunity. There's a lot of money that's going to be spent. And if we don't build the capacity within the UK, we're going to be buying these things in from overseas. And that's going to do 2 things. It's going to cost us money, but it's also going to end us with a lot of embodied carbon, and we won't be making our net zero targets. So next slide. For those of you who are SMEs, we have a scheme for SMEs. Please talk to us about it. We would like, if you're in this area, to work with us. Next. And we also do other things that impact on the chemistry and chemistry using industries. We have a meeting on big data and artificial intelligence coming up, engineering, biology, and the battery materials meeting on March the 14th. If you have any questions, please talk to us. Please ask questions. Thank you for your time this morning. I hope that was useful. If it was, ask more questions. If it wasn't, tell us and we'll do something else next time. Thank you very much, everybody. I hope you have a good rest of the day. Take care.